So this is 10.3, operations with radicals. It's the next section that we're going to be doing. Basically, when you're working with radicals, you will treat it similar to when you were working with just variables. The only difference is that you want to make sure that you simplify the radicals as much as you can. So when you're combining like terms, just like if you had a variable, you can only combine radicals that have the same radicand, which means the number underneath the radical. If they have different numbers under the radical, you can't combine them. And that's assuming that you have simplified it first. So let's look at this one. It says the square root of 5 plus 6 square root 5. Well, we can assume that this is 1 square root 5. I don't have a marker working here. 1 square root 5. So since they have the same radicand, we know that we can combine them. So it becomes 7 square root 5. Same thing with the one over here. 12 square root 5 minus 3 square root 5. Since they both have the same radicand, square root of 5, all I have to do is subtract the numbers in the front. 12 minus 3 is 9. 9 root 5. This is just like if it was an x. 12x minus 3x, it would be 9x. Same thing. Now look at this one. The one over here, they don't have the same radicals. But they can be broken down. So the first thing I want to do is I want to break them down as much as I can. So I have 9 times 5, 3 times 3. So here's my pair, which is 3 radical 5. Since there was already a 3 on the outside, I have to multiply those together. So that gives me 9 radical 5. Then I break down this one. 10 times 2, 5 times 2. So here's a pair. 2 radical 5, because the 5 stays on the inside since it has no pair. And since there was already an 8 on the outside, I have to multiply those together, which gives me 16 radical 5. Now they have the same root. Now they're like terms. So I can actually combine them. So that becomes negative 7 radical 5. Look at the one next to it. I want you to try to do the same thing. Break them down. See if they have the same radicand, and if they do, then you can combine like terms. Okay, go ahead and check your answer. See if you got 22 radical 2. Alright, let's move on. So the distributive property works the same way. When you multiply radicals, you multiply the outside with the outside and the inside with the inside. So let's go ahead and try this one. Oops, I gotta get my pen again. So remember that there's nothing outside of this radical 3, so it's automatically a 1. So 5 times 1 is 5, and square root of 11 times square root of 3 is square root of 33. Then we multiply this one. 5 times 3 is 15. And square root of 11 times square root of 2 is square root of 22. Okay, go ahead and try the one next to it. Just multiply. I know the 4 doesn't have a radical, so you can just multiply the coefficients together. Alright, check your answer. So when you did this, you got negative 4 radical 12 and positive 2 radical 36. The 36 breaks down to 6 and 6, which is a perfect square. So 6 times 2 is 12. And the 12 breaks down to 2 radical 3, but since there was already a 4 on the outside, it becomes negative 8 radical 3. What's left over is not, they are not like terms, so you can't combine them. So that's your answer. So when you have to FOIL, it works the same way as well. I'm going to go ahead and multiply the first one with the first one. So I get square root of 12. Outer, negative 2 radical 6. Inner, positive radical 6. And last, which is negative 2 radical 3. I have like terms here in the middle. So negative 2 plus 1 gives me square root of 12 minus 1 radical 6 minus 2 radical 3. I can also break down this 12. So I'm going to go ahead and do that. So I get 2 radical 3 minus radical 6 minus 2 radical 3. Here are another set of like terms. So those will cancel. And I'm left with just negative radical 6. Go ahead and try the one next to it. See how you do with foiling that one. Okay, so if you check your answer, oops, should have gotten that. You end up with no like terms, so you can't combine anything there. Let's look at some special cases. So the first one you'll be able to recognize as the difference of squares. They're exactly the same, but one's a plus, one's a minus. So I can FOIL out the whole thing, but my middle terms are going to cancel. So all I really have to do is first and last. And even then, I don't have to write square root of 25 because the square root of 5 times the square root of 5, it's the square root of 25, which is just 5. And the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So my answer is 2. And this special case is a perfect square trinomial, so you have to remember to write it out twice. You can't just distribute the exponent. You can never distribute an exponent over a minus or a plus. So I have to actually write the parentheses 2 times and then FOIL. So I get 25 radical 4, which is 2. So 25 times 2. Here I get negative 10 radical 6. Here I get negative 10 radical 6 again, since they are the same. And then I get positive 4 radical 9, or just 3. So I get 50. These two are like terms, so minus 20 radical 6 plus 12. And 50 plus 12 is 62 minus 20 radical 6. So go ahead and try the ones below. See how you do with those. Okay, so let's look at those answers. If you notice the first one, difference of squares, I went ahead and FOILed the whole thing out so you could see that the middle terms will cancel. So all you have to do is the first and the last one. Make sure that you can recognize that it's difference of squares, or else you're going to make that mistake if you do it when it's not. So I ended up with just negative 6. Second one, I wrote it twice. And then I distributed, and I ended up with 106 plus 6 radical 77. The last concept when you are doing operations with radicals is when you have a radical on the bottom of a fraction. And you can't have a radical on the bottom of a fraction. It's not proper. So you have to do something called rationalizing the denominator. And so we've discussed already when you have a radical on the bottom that you multiply by that radical. But sometimes you're going to have a binomial with a radical on the bottom. And you can't just multiply by that radical, you have to multiply by something called the conjugate. The conjugate is exactly the same thing, but with the opposite sign. We may have gone over this already, but just in case. The conjugate of this one, for example, would be the same exact thing, but with a plus instead of a minus. So it'd be square root of 13 plus 2. Conjugate of this, same exact thing, but with a minus instead of a plus. Square root of 6 minus square root of 3. And the conjugate of this, same exact thing, but with a plus instead of a minus. So let's look at an actual problem. Because this one has a binomial on the bottom, we have to use the conjugate to get rid of it. So we're going to multiply by the conjugate, which is the square root of 2 plus 1. Same exact thing, but with a plus instead of a minus. Same thing on the top. We have to do both top and bottom. Now why do we do this? Because this creates a difference of squares on the bottom And that way it'll eliminate my radicals on the bottom. So let's see, up here I'm going to distribute. So I get 5 radical 2 plus 5. And down here, it's a difference of squares, so I only have to do first, which gives me radical 4, which is 2, and last, which gives me negative 1. So now I have no more radical on the bottom. So I have 5 square root 2 plus 5 over 2 minus 1, which is 1, and I don't even need to put that because it's a 1. Let's look at it again. Here my conjugate would be 2 plus 2 radical 3. We'll do the same thing on the top. And I put the parentheses because I don't want to forget to distribute. So I go ahead and I distribute the top. Negative 2 minus 2 radical 3. And then on the bottom I only have to do first and last. So 4 minus 4 radical 9. So the top stays the same, but on the bottom radical 9 is actually 3. Right? So I could just multiply that with the 4. So it becomes 4 minus 12. So now I have negative 2 minus 2 radical 3 over negative 8. But now this I can actually reduce, because up here I have a GCF of negative 2. So if I take that out, I end up with 1 plus 1 radical 3. And now I can reduce the negative 2 and the negative 8. So that becomes a 1, and that becomes a 4. So my answer is 1 plus 1 radical 3 over 4. So just to recap, multiply by the conjugate, I ended up with this, but I had a GCF, so I took out a GCF, and then I can reduce with the bottom. Go ahead and try these two problems. Okay, let's check the answers.